Hi there guys, and today I'm going to be taking you through my setup of the Raspberry Pi Kubernetes cluster. It's taken me a few weeks to put together this process. There's several challenges along the way that I came up against, particularly running it on a Raspberry Pi. But what we're going to do now is we're going to go through the whole process from flashing the SD card all the way through to having Grafana running and monitoring our stack. And it should not take us too long, although it's taken me a long time to get this process down. So the first thing we're going to do is we're going to flash our SD card. So we're going to choose, obviously it's a Raspberry Pi 5 that I'm working on. I'm going for a no GUI kind of headless installation. So we go for this no desktop environment, small, lightweight, as we're running on baby computers here. And then choose storage. I'm going to flash this to my SD card. Now I'm going to call this in my host name. This is going to be my Pi head node 01. I'm putting 01 because I'm going to add more head nodes later. I'm going to have additional Pis working as head nodes, so I've got redundancy there. Then I'll have various worker nodes. So our username for this is going to be Pi head node, and then just set whatever password you want. I've got Wi-Fi turned off, just to give you a little background as to what I've got set up, I actually have a Pi already running, which is running Pi-hole, which has two Ethernet connections. So I've got the native Ethernet 0 connection on the Pi, and then I have a USB to Ethernet adapter, which gives me a second connection. That second connection is going out to my network. So two separate subnets, and all of the forwarding and everything was all being managed by Pi-hole basically. So Pi-hole is my DHCP server, it's a DNS server, and a router forwarding traffic out. So everything on my cluster is going to be on a 10.5.5 subnet, and all of the traffic, if it wants to get out to the internet, outside world, it has to go through Pi-hole. So that's basically the setup I've got. So I've got my laptop in the 10.5.5 subnet connected to the same network that my Pis and everything are all going in. So I'm going to turn off the Wi-Fi because I'm not going to need that. And we can just go to save here, and we will continue and flash our card. So that takes a few moments to be done. While that's doing, I'll just talk you through this. So I have kind of a cheat sheet here that I've been setting up as I go along. So every time I found something that worked, I made notes of it, and this is kind of the process that we're going to be going through. Now there's a couple of things here we're going to skip. So we're not going to need to set up networking in DHCP because I'm actually doing that through Pi-hole. But if you were setting up a standalone cluster, then you would need to go through that procedure, but I'm not going to cover it in this video. So basically, we need to set up the NTP. That's something that I found was not working kind of out of the box. So I had to get NTP working, make sure the clock's correct. And then we kind of go straight onto installing Kubernetes, which I have put together into a script. So all of this is in kind of a script that we'll be able to run, which will get K3s actually installed and set up really quickly. It's really quite easy. So let's see how that's doing. So after doing that, I'm not going to set up the external SSD right now. But there's a few things that we actually have to do before we install K3s, which are also included in the script. So that is, we need to turn off swap files, we need to set the swap file size to 0, and then we add these to our command line.txt file. So this is something that's run during boot, so you have to reboot. So there's a few little things that we had to do to get this to work on a Raspberry Pi. See if that's done. Yes, it is. Excellent. Okay, so now we can go ahead and put our SD card into our Pi. My Pi is just over here, sorry. There we go, and we'll power it up. Now that will come up already with a static IP address. I've already configured all of that through Pi-hole. So here is my Pi-hole here. Let me just grab the password for this. We'll log in. So this is my Pi-hole interface here. And if we go down to the DHCP, we can see these are the various nodes I've got running. And they've all got these reserved static IP addresses, so I've reserved them here. It's always good to run the cluster on static IP so you know what it is you're connecting up to. So our head node is going to be on 10.5.5.2 because our 10.5.5.1 is the Pi-hole. Okay, so that's where we're going to be starting from. And now we'll go over to our terminal and we're going to SSH into the device. It should be already ready. So I've already set up actually a local DNS for the head node. So we can get to it through SSH, and we set pi head node at pi head node 01 cluster. Now I got this error, and that's only because I have previously SSH'd into this before I flashed the card. So all I got to do is go sudo nano users nic.ssh known hosts. Now you're not going to have to do this if you have, make sure I typed all that in correctly. Users nic.ssh, not ssh. There we go. You're not going to have to do this if you have not previously accessed it on a different installation. So we just clear that, and now when we SSH in, we get no problem. So pi head node was our no, Raspberry cluster is the password I'm using. So now we're SSH'd into here. We're going to create the script. So we're going to go nano config ntp.sh, and I have a ntp script that I have already prepared, which I'll put a link to it in the description below. So now we'll go chmod plus x config ntp.sh sudo /config ntp.sh, and that is going to run our script, and it should get our NTP clock all nicely prepared and synced. So once that is done, we'll move on to the next stage, which is basically going to be installing K3s. So what we're running here at the moment is the clock sync here. So that script is basically running all of these commands here for us. We're not going to do setup networking DHCP because we already have that through Pi-hole. So I'm going to go straight onto then the K3s setup. Now again, I have a script that basically manages all of this for me. So all of this stuff here that I figured out I need to do is now in a simple script. So we'll go to nano config k3s.sh, and we'll grab our K3s cluster script that I have here. I'll copy this into there, and then same chmod plus x config k3s.sh, and then sudo /config k3s.sh. That will now do its thing, and it will install for us K3s. So at the end of this, we're going to have Kubernetes running already. So it's quite easy and straightforward. After the installation, there is something that we're going to want to do, which is we're going to need to grab our node token, because we're going to need that later on when we set up our nodes. So that I haven't put into the script actually, but I should really put into the script, printing out at the end the node token, so you can just copy and paste it from the terminal window, so you don't have an extra command to run. So we'll just wait for K3s to finish doing its thing. Almost done. There we go. Now it is going to restart the system and probably kick us out of SSH. There we go. So rebooting. We'll just give the Pi a moment to reboot, and then we'll SSH in again, and we will grab the token. Still not booted up yet. There we go. Now we're in. We'll run this and grab our token. Now I'm going to save that here because we're going to need that later on. Okay, so now if we do kubectl or cutl get nodes, we should see we now have our Pi-head node already up and running. Okay, now the next thing I'm going to do is I'm not going to set up another node yet. What I'm going to do actually first of all is I'm going to install MetalLB. So this is going to handle load balancing and issuing IPs for the various services that we're running on our cluster. So we'll start off with this command here. Now I haven't put this into a script yet, but it's pretty short, so it doesn't really need a script necessarily. So once this is done, we can check the deployment. So you can see here now we've got containers creating, and we just need to wait until these are all running and it says 1 of 1 is ready. Okay, so it does take a few moments. So the first one's up and running, but I do find that the speaker takes a little bit longer. The speaker pod takes a little bit longer. There we are. Okay, so now we've got everything running. We're going to create now a configuration file, which we'll call address pool. So that's nano address, put it correctly, address pool .yaml, and we'll put this into there. Now what you're going to have to do here is change the IP range to your particular subnet. So we want to issue IPs on the 10.5.5.50 up to 100, I think. It depends on your configuration. Let me just double check what my DHCP is here. Okay, so my DHCP is issuing values up to the start address is 10.5.5.150. Yeah, so I'm going to actually do a bigger range then for this. We'll say we can go 10.1.5 up to 150. Okay, so our load balancer has an IP addresses from 10.5.5.50 up to 10.5.5.150. Actually, we'll make it 149 because DHCP starts at 150. Okay, and we'll make this, yeah, that's okay. That's all good. So we'll save that. And the next one we're going to create is called advertisement. So this will be nano advertisements.yaml, and we copy into that this. Save that, and now we're going to deploy both of those. Sorry, it's address pool. I didn't put a hyphen there. There we go. Okay, so now they are both deployed. We're going to deploy a test for this now. So we will run this, and what that should do is it will create for us an Nginx load balancer service. Okay, and you can see it's been given an external IP address from MetalLB. Okay, if we didn't have MetalLB installed, this would say pending. It wouldn't get an IP address. So it's been assigned 10.5.5.50. Now, if we go over to a browser and we go to 10 http /10.5.5.50, you'll see now we get our welcome to Nginx loading. Okay, I'm just going to close those off. Okay, so we've verified now that our load balancing and MetalLB is working, which is great. So in not very much space of time at all, we've set up our Pi. We've got a K3s cluster head running. We've got MetalLB load balancing configured. And next thing we're going to do is install some monitoring with Grafana. So we're going to install a Prometheus Grafana stack. So the way we're going to do that is we'll curl out and download and install. There we go. So that's done. Okay. And then we were going to create a Helm repository. So what I did there is I just installed Helm because we're going to use Helm charts to install the Prometheus Grafana stack. If you don't know what Helm charts are, don't worry about it. Just follow along with this and everything should work out okay. Now, we do get this error here, which I have encountered before. Now, this sometimes is basically related to not being able to access the K3s file. So it takes a few moments to fix that. So I'm just going to pause while I fix that, and then I'll come back in a moment. Okay, so yeah, I had to go over to ChatGPT and get a little bit of help on this because I ran into this problem before, and I used ChatGPT to help me out. So I had to run this command here, which basically kind of copied the kube config to my home directory, so Helm is able to get access to it. I'm not really sure exactly why, but anyway, let's run this again now. Fingers crossed, this should have fixed the problem, and it should this time install. Go back over to my cheat sheet here. So yeah, so we need this. Okay, so because it's already created the namespace, if we go to kubectl get namespace, you'll see we already have monitoring there. So we'll do kubectl delete namespace monitoring. Just give that a moment to run. Okay, so now we should see it's gone. And now we should be able to run our install again. Let's try that out. Hopefully this time no errors. So I think I need to add actually into my cheat sheet this command from that I got from ChatGPT that fixes that installation problem. There we go. So now it's done. So yeah, I'm going to just keep this handy. We'll put it in here into my cheat sheet, so that needs to be run before anything else. Okay, so now this is up and running. If we go to kubectl get pods namespace monitoring, we should see them all running now. Okay, so they're all up and running. Now, what does Prometheus and Grafana do? It monitors our cluster for us. It's very important when you've got a K3s cluster or any Kubernetes K8s cluster running that you monitor it. There's a lot going on and you need to keep on top of it. And plus it just looks really cool, having a Grafana dashboard monitoring all this stuff. So now if we change get pods to get service, SVC, we'll see we've got those. But these have no external IPs. So we cannot access any of these services right now. So what we're going to do is upgrade or change the types to a load balancer. Then they will get an external IP from MetalLB. So we run this, and you see this is a Helm chart, which will update to a minute. I think these maybe should not be in quotation marks. Hold on. This word. Called KPS is the name. It's just the naming here. Let's just take these out of quotation marks for a moment. Not sure if that's the problem there. Try it again. So this looks like it's running now, is going to update the Helm chart to set Grafana, Alert Manager, and Prometheus services to a type equals load balancer. And once this is done, now when we do get service, we should see, okay, get pods, we want to get service. We'll see here now they've got external IPs. Great. So you'll see there's a little note here, right? So to get the Grafana admin password, run this. So this is something that you're going to need to run. And that gives us our Grafana admin password, which is prom operator. Now you're going to be able to change this when you first log in, but we'll just stick it in here. So we're going to say Grafana. So it's admin, and the password here is prom operator. Now, what we will do is go over here, we'll open this up, and so this has been given a cluster IP for Grafana of 51, so 10.5.5.51, so HTTP 10.5.5.51, and that brings us to Grafana. We put in admin, prom, operator, and there we are, we're now in Grafana. Now the cool thing about installing it from the Prometheus Grafana stack is it already comes with a bunch of pre-configured dashboards that we can go over to. So if we go over here and we take a look, say, at the Kubernetes API server, at the moment we've got no data because this has only just started running. So it's going to take a few minutes for some data to start coming in. But basically, you're going to be able to start seeing information. So here's some already here. So this is already showing us here CPU usage. It shows us the various services which are running on our nodes. So here you can choose the node. At the moment we only have one node, but you could see here the CPU usage per node, memory usage per node, and over time these graphs are going to be created. Now there's something that you're going to have to do, which is persistence. So what I mean by that is if this pod restarts, you're going to lose the data. Okay, I think the term is that the Kubernetes pods are ephemeral. So they do not retain the data. So you have to set up a persistence claim, which is something we'll show in another video. I'm not going to go through it here because otherwise this video will just get too long. I just want to show you just how to get quickly up and running. And basically here we are, we have now a Kubernetes cluster. We've got MetalLB, load balancing. We've got Grafana. Now there's a couple of other services there, Alert Manager and Prometheus. So Prometheus is basically scraping the data. Alert Manager can manage alerts, although I do them through Grafana. And all of that data that's being scraped by Prometheus from our Kubernetes cluster is being thrown up here into this Grafana dashboard. So there's a ton of stuff now that you can actually do. There's something else that we can install called Rancher, which again I'm going to go through in another video. But Rancher basically gives us another way of managing our cluster. So Kubernetes for monitoring and Rancher for managing it. But that's it. So now we have another Pi that we're going to set up. So I have another Pi which is going to be our worker node. So I already have the SD card here. And basically we're going to have to flash this one. So we'll choose our storage. Shows up, and now this one is going to be our worker node. So we're going to change this from Pi head node to Pi worker node, and we change this to Pi worker node as well. Pi worker node, make sure that's all correct. Yes, okay, save, and yes. So now we are going to configure this. So we've got another Pi which is going to join our cluster basically. So we skip back on my cheat sheet here because we skipped over it. So setting up or adding a worker node. This is basically the procedure. Now it's a little bit different to setting up the head node, but not much. So you run these commands, which I also have in a script, but this time we're just going to run them manually just so you can see actually what's going on in the script. If you don't want to use the script and you want to do it manually, then this will give you the ability to do that. So once we finish burning that SD card, we will get the worker node set up. So you know, I'll just cancel verifying. We'll assume that it's worked properly, just for the sake of brevity. And okay, we will boot up our worker node now. Sorry, I don't have everything set up nicely like some of the YouTubers with, you know, a nice rack with everything in it. My stuff's all over my desk, so I can't really show you the Pis. They're behind my computer over there, but I'm sure most of you know what a Raspberry Pi looks like. So I can hear the fan going now. That's booting up. Once this Pi boots up, it should come up actually with its fixed IP address that I've already assigned it previously in Pi-hole. So that just makes this video a little bit quicker. But if you haven't done this Pi-hole part already, then you're going to have to find out the IP address that's been assigned, or some other method of, you know, finding out how you can access this particular Pi. But I've already set up here in Pi-hole the MAC ID of that Raspberry Pi and the address that I want it to get. So this is going to come up as Pi worker node 1, and it should come up with 10.5.5.4. So over here we should be able to ping 10.5.5.4, and you can see now we're getting a response very fast because we're on a gigabit network and there's nothing in between it. It's a very short cable going between these Pis here. Okay, so now we have that set up. What we can do now is SSH into that Pi. So we can actually exit our head node, and we can go SSH into Pi worker node. Pi worker node 01, and our username for this one is Pi worker node. Pi worker node 01.cluster. We should be able to get into this. No, it's got local. I don't think I just defined a one for that yet. There we go. Okay, and password to get into this. Okay, so here we are now, SSH'd into our worker node, which has not yet joined our Kubernetes cluster. Now I'm going to do something cool. I'm going to open up another one here, and we will SSH into our head node again. So SSH Pi head node at Pi head node 01.local. Okay, now we got this command here, kubectl, kubectl get nodes. So that shows us at the moment we only have this one node. Now, if we put before this, we'll put watch, which will make it live updating, and then we're going to make this O wide. Okay, now we get a bit more information about what's going on here. So you can see the nodes, their IP addresses, and so on. Now, because we put this in watch, this is kind of a live view. What you're going to see as we set up our worker node, you're going to see it appear here when the setup is complete. So let's jump back over to our cheat sheet. So first of all, on our worker node, we're going to set swap files to off. The reason that we do this is because Kubernetes kind of likes to write files quite often, and if things are kind of moving around, it can cause problems. So setting the swap files to off really helps. So next we add this. So in our command line here, we're going to add this to the end of it. Okay, and we're going to have to reboot after adding that line. We need to reboot. Okay, after that we need to then also run the NTP server script that I've got. So I think that's almost booted up. Okay, so then we'll go nano config ntp.sh. We'll grab our NTP script, save this, chmod +x config ntp.sh sudo /config ntp.sh. And this should run it and get our clock synced. Once that is done, the next thing that we're going to do is install K3s, but we need to make sure that we have our token and the IP address of our head node. So I know the IP address of my head node is 10.5.5.2. Okay, but then we also need to put in this token. That's my old token from previous installation. This is the new token. Remember I said to save it earlier? So we're going to insert that into here. That's our new token. And then we'll just tidy this up, make everything black, make everything white, make everything 11. Okay, so now we have that. NTP should be done. We'll run this. And if we watch this window here, you'll see once it is installed, if everything goes to plan, you'll see it join our cluster here, and we'll see Pi worker node 01 joining our Kubernetes cluster. And there it is, Pi worker node 01 on 10.5.5.4. So that's it, folks. We now have a K3s cluster running on our Raspberry Pi with Kubernetes K3s, with Grafana, with MetalLB load balancing, with Prometheus, and from here on in you can kind of run with it however you want. Now I'm going to be doing more videos which will show more about what I'm actually doing with this cluster, and we've still got work to do. We've got persistence to set up so that our Grafana graphs don't disappear. Got some other things that we'll set up as well. So to do persistence, we need to put on something called Longhorn, and we'll set up an external kind of, I've got this external SSD drive here, which we'll set up for storage, kind of a NAS setup. So there's things still to do. But this is the basics of how to get a Raspberry Pi Kubernetes cluster up and running. So don't forget to like and subscribe if you found this useful, and I'll see you in our next video.